Hello, this is Mr. Huber. In this lesson, we're going to look at rational expressions. A rational expression is simply anything that can be written as a fraction with a numerator and denominator. And so to reduce rational expressions, we want to look for common factors in the numerators and denominators. The first example we're going to state here is 8 over 20, just a common fraction like you've seen before, not even a rational one like we're going to see over here. So 8 over 20, how do we know how to reduce it? You may think, oh, I can divide them both by such a number, okay? Well, the reason you can do that is because you could write the 8 as 4 times 2, and you could write the 20 as 4 times 5. That's why we're able to cancel out the common factors of 4, divide them both by 4, if you will, and get 2 over 5 as our answer. So when we look at rational expressions here, which 8 over 20 is a rational expression, but now we're going to see ones with polynomials in them, okay? We want to look for common factors. That is things that are multiplying. So here, x plus 1 is a factor, because that whole x plus 1 is multiplying x plus 4. X plus 1 is also a factor in the numerator, because it's multiplying with the 2x. So I can reduce, cancel out, if you will, the x plus 1 and x plus 1. And I'll be left with 2x over x plus 4. What you want to be careful of not doing now is do not cancel out these x's. These are not common factors. This is not a factor in the denominator. It's x plus 4. If it was x times 4 and it was a factor, we could cancel it out. Okay, if this was 4 plus 2 and 4 plus 5, we couldn't cancel out the 4's. So we can't cancel this out if it's adding to the 4, only if it's a factor. X plus 1, the whole set of parentheses there, that whole binomial, is a factor. X plus 1, the whole binomial is a factor, so we can cancel them both out. And you notice in the directions, other than simplify, we need to, and, so we don't forget to do that, state any restrictions on the variables. So restrictions are where we'd have a denominator equal to 0. Okay, before we canceled anything out. So in our original fraction here, we would not be allowed to have an x value of -1 or -4, right? We can set each factor equal to 0 and see what values would be excluded. So we would be able to write that in our restricted values as x cannot be equal to -4 or -1. It doesn't matter what order you write them in. Don't put parentheses around, it's not an ordered pair. Okay, so this whole thing here would be our answer. That's the simplified expression, and then the restrictions on the x values. Then if we look at the next example, okay, one of the things we're going to need to do is factor the numerator and denominator. So this numerator can be factored to 4 and x plus 5. We can take out a common factor of a 4. And then the denominator, we're going to factor to 2 binomials. Okay. Since it's a plus 30 and a plus 11, we know we're going to have 2 plus signs there. We need numbers now that multiply to give us 30 and add up to 11. So 6 and 5. So now we've got the numerator and denominator both factors. Now we can look for common factors. Again, we don't want to come in here and go, oh, I can divide 4 by 2 and 30 by 2. Those aren't factors. Now we've got x plus 6 and x plus 5 are factors. X plus 5 and 4 are factors. The common factor, x plus 5 then, can be canceled out of the numerator and the denominator. And so we're going to have 4 over x plus 6. Okay, 4 over x plus 6. And we want to look for any restrictions on the variables. So in this case, x cannot be equal to -6 or -5. Okay, again, by using our original fraction, we take each of these factors, we could set them equal to 0. We write x plus 6 equals 0 and solve. That would be an x value of -6. Okay, if I plug -6 in here to the denominator, I would end up with a 0, which is not allowed in my denominator. Can't have a denominator that has a final value of 0. Okay, let's see here another example. So x plus 4 over x squared minus 16. This denominator is one of our special factoring patterns. It's a difference of squares. We want to recognize that as x plus 4 times x minus 4. X times x is x squared. 4 times 4 is 16, and it's a difference of squares, so we have one with a plus and one with a minus. If we FOILed this, the middle terms would be -4x and +4x and cancel each other out. That's why we have no middle term here. We just have the x squared and then the minus 16. And so now we can look for reducing this by canceling out the x plus 4 and x plus 4. In this case, since the denominator completely cancels out, it becomes a 1. It cancels out to 1. And then our denominator, our numerator, excuse me, is 1. Our denominator is x minus 4. And our restrictions on our x values are x cannot equal plus or minus 4. Right? We can't have a positive or a negative 4 in our denominator. Okay, so reducing by finding common factors, and look for restricted values that you can't have in your denominator to make that equal to 0. Before we see some multiplying and dividing with rational expressions, I know you're anticipating that highly, but let's take a little break for a World Cup winner trivia. What country won the first soccer World Cup championship in 1930? The first World Cup was in 1930. It was hosted in Uruguay. That's their flag right there. And they, in fact, were the winners of the 1930 World Cup as well. They got to host it because they had won the 1928 Olympic gold medal. And there were 13 teams competing in 1930, including the USA, which won their group, went on to the semifinals, and lost to Argentina 6-1. And then Uruguay beat Argentina 4-2 to capture the championship on their home stadium. All right, so Uruguay, or Uruguay, I think is more locally how it's pronounced, but we'll go with the more English version, Uruguay. Okay, let's look here at some multiplying rational expressions. If you recall from multiplying fractions, you can reduce them before you multiply. That makes the work at the end a little easier. So let's look at how we can do that. We can only reduce between numerators and denominators. When you're multiplying, it can be between either of the fractions as well. So if we look here, we have a 3x to the 5th. Okay, this 3 is a factor in the numerator. It can be reduced with the 9 here, and that can become a 3 and a 1. Okay, the x to the 5th can reduce with the x to the 3rd in the denominator. If I cross those out and those out, x to the 3rd crosses out completely. That'd be like a times 1 there. And then this would be x squared, because I took away 3 of the x's from the 1 and the 3 in the denominator. Now I look at the y's. This y can cancel with one of these y's, so that'd be y to the 1st. And now I can multiply my numerators and denominators. It doesn't look like there's anything else that can be simplified. So in my numerator, I am going to have 1 times x squared times 7 times x times y to the 1st. So let's look at the numbers first. 1 times 7, that's going to give me a 7. Then I have x squared times x is x to the 3rd, and then I have y to the 1st, which I just leave as a y. Over, and in my denominator of 8 times 3 times 1, so there's 8 times 3, that's 24. And we can look now and make sure there's nothing else that can be reduced or simplified, which there can't, so that would be my final answer. Okay. In number 8 over here, and we're going to want to look at factoring this first so we can see where there's common factors that can be canceled out. So in my numerator, it'll be 2x, and then x minus 5. Difference of squares, so x plus 5 and x minus 5. And then nothing in the second fraction can be factored, so we'd look now to see if there's anything that can cancel out. Hey, yeah, there's an x minus 5 and an x minus 5. That's great. I've got this 2 and 2 cancel. This x cancels with one of these. It just leaves me an x there. Okay. Remember, I don't need to look at those anymore because I factored them. Okay. So now in my numerator, all I have is an x plus 3. So that would be x plus 3. And in my denominator, I have x plus 5 and times x. So that's going to be an x squared plus 5x. Okay. We can't factor that, we can't reduce that anymore. There's no common factoring, and we don't want to cancel this x out with anything down here because it's not a factor in the numerator. Okay. And then let's look back now. I'm going to state any restrictions. So I just want to talk about multiplying them first. Now let's talk about restrictions here. We want to go back to our original problem. Okay, so I'm going to do some erasing here just so we can see the original problem again. But remember, we had those there to cancel things out. That's fine. Okay, so when I look at restrictions in my numerator, or excuse me, in my denominator in this first problem, I can't have a y that's equal to 0 or an x that's equal to 0. So to have y not equal to 0, x not equal to 0. That would be my restrictions. Okay, because I can't put a 0 in here or here. 8 times 0 would be 0. 0 cubed times 9 would be 0. Okay, so I can't have x or y be equal to 0. Now I come over here again. I want to look at my original denominators. So I have the x plus 5 and x minus 5. So x can't be 5 or negative 5. And over here, x can't be 0. So my restrictions for this second problem are going to have x not equal to 0. x not equal to plus or minus 5. And so that would be my answer there. Okay, so again, reduce, then you can multiply numerators and denominators, and then look for any restrictions on the variables. Okay, let's try another one here. Okay, you should be trying these too as we're going along. You'll be able to tell if you're on the right track or not. This second fraction, we want to write over 1. It'd be like if I have the number 10. 10 can be written as 10 over 1. Okay? And so now, in my first fraction, if I wanted to factor this, it would be x plus 1 and x minus 1. Again, we see another difference of squares. And number 9 there is going to be, in the second fraction, 2x plus 3 and x plus 1. Okay. So now, if I look at this, I can look for anything that will reduce here, and I can see some reducing that I can do. I've got the x plus 1s that will cancel, right? And so my numerator now is x plus 5 and 2x plus 3 over x minus 1. And we could multiply, FOIL the x plus 5 and 2x plus 3. If you do that, you're going to get 2x squared plus 13x plus 15 over x minus 1. With restrictions on the variables, where x cannot be equal to plus or minus 1. Okay, we don't have to worry about any restrictions over here. There's no variable in the denominator. But here we can't have a variable with x equal to negative 1 or positive 1. So this would be our answer. And lastly, we're going to look at some division, okay? It's not too different from the multiplication, all right? You may be thinking that's good or bad here. We'll see. Okay, so one thing you want to remember is that when you're dividing by a fraction, that's the same as multiplying by its reciprocal. So what we're going to want to do here in this first problem is turn this into not dividing by x squared minus 2x over x squared minus 6x plus 8, but flipping this over, okay? We want to multiply by the reciprocal. So this is going to be the same thing as times x squared minus 6x plus 8 over x squared minus 2x, okay? I wrote this as the reciprocal, right? Keep, change, flip. Keep the first fraction, change the multiplication, flip the second fraction over, okay? And now, I want to factor anything I can factor, so I'm going to write this down below here. I have 4x over, and I can take out a 5 from both terms there, times. This numerator can be factored to x minus 4 and x minus 2. And then here we can factor out an x from both terms. Okay? So I factored x squared minus 6x plus 8. Those two numbers multiply to give me 8 and add up to the negative 6. And here I can take an x out of both terms and factor that out. So now I can look at any reducing, x minus 4 and x minus 4, x minus 2 and x minus 2 can cancel, this x can cancel with this, and I'm just left with 4 over 5. That's my final answer. That whole thing reduces to 4 over 5. And my restrictions on my variables, this is where it's a little different than the multiplying. Okay, we don't want to have this denominator equal to 0, and we can't have any of this fraction have factors that will make it equal to 0. Because remember, we were dividing by this whole fraction, so if any part of this is 0, it won't work. So we have to look at the factors in the numerator and denominator in the second fraction. So we can't have x values of 4, which would be a common factor in both these. So we can't have x be equal to 4, or 2, or 0. It can't be equal to 4. It can't be equal to 4, we already wrote down. It can't be equal to 2. It can't be equal to 2, so we included the 2. And it can't be equal to 0. So x can be anything but 4, 2, and 0. So make sure you're looking for those restrictions, and in the division, make sure you're looking at everything that would make this second fraction equal to 0. Okay? In the second example here, number 11, the second division example, okay, we want to turn that into multiplying by the reciprocal. So we're going to turn this into multiplying by the reciprocal. Instead of 2x squared plus 5x over 1, the reciprocal will be 1 over 2x squared plus 5x. Now I can factor. Okay, the factoring in this first numerator can be a little tricky because you have the 2x and the x. Okay, and then you want to find numbers that multiply to give you 5. Well, that's only 5 and 1. And so you can play around with it a little bit and get plus 5 and minus 1 here. If you go back and look at this, 2x times x is 2x squared. 5 times negative 1, okay, is negative 5. Negative 2 plus 5 will give me the plus 3x in the middle. Okay, so again, working on factoring. If you need some help with that, make sure you're practicing it. See me where I can help you out. And here we're going to have 2x, excuse me, not 2x. We don't want to take out the 2. Okay, we want to just take out the x. Okay, and then we're going to have a 2x inside there. So I was jumping ahead of myself a little bit. So we're just going to factor out an x, and then we'll have 2x plus 5. Okay, one thing you want to look for is how can I get a common factor? So maybe you factor this first, and you get x and 2x plus 5. Then that means you should maybe look to see if you can get 2x plus 5 as a factor here to make it worth factoring so you can reduce something. Okay, so we have 2x plus 5s that'll cancel. And that's it. Okay, so now in my numerator, I'm going to have x minus 1 times 1 is just x minus 1, and my denominator is 6x times x, that's 6x squared. So I get x minus 1 over 6x squared, and here x cannot be equal to 0, right? If we look at our denominator here, we can't put in a 0, and then we look over here, it can't be equal to 0, which we already have. And now this one, again, you might want to set that equal to 0, if it helps, if you can't just kind of visualize it or mentally do it. We'd want to write, and I'm going to put it up at the top a little bit here, we'd want to write 2x plus 5 equals 0. We subtract 5 on both sides, we get 2x equals negative 5, and then we divide by 2 on both sides. X equals negative 5 over 2. So we can't have an x value of 0 or negative 5 over 2. That would be our simplified version and our restriction. Don't forget our restrictions on what variables we can use, that we can't have denominators equal to 0. So again, these are a lot like any other fractions you've seen, just going to be a little more complicated to work with at first. It'll take a little while, but again, reducing using common factors. When you're multiplying, reduce then multiply. When you're dividing, keep, change, flip. After you keep, change, flip, now you got just like a multiplication problem where you're looking to reduce and then see what you can do with the multiplication from there and look for any restricted variables.